What kind of explanations the evolutionists have? Well, they say that the feathers maybe were started out as scales, and then the scales got frayed, and then the frayed scale sort of frayed a second order to produce branching, and then it branched to third order, and somehow all this became a feather. So the way the argument used to go is that birds evolved from reptiles, and they said reptiles have scales. And by the way, I had a lab tech with a boa constrictor, so I had to bring the skin in from the boa when he shed his skin, took a picture of it. Evolutionists say something like that, through shredding and fraying and what have you, turned into a bird feather like this. Man alive, it doesn't take faith to believe that, it takes credulity. Credulity is the willingness to believe without evidence, without any evidence at all, and there's none.
I have all kinds of evidence, and all you have is credulity. Unlike me, you have a belief system of required beliefs and prohibited beliefs, which demands that you be credulous. You pretend to believe in what are literally fairy tales, fables with a moral, which feature witches, wizards, giants, dragons, magic spells and enchantments, and animals that talk and act like people, all without any evidence to support any of that at all. You reject scientific facts knowing that you are denying reality, and you maintain an unreasonable belief even in things that you know have already been proven false. The point here is that science doesn't work like a belief system. Instead of claiming certainty and absolutes, everything we know to be factually accurate is still regarded as theory and constantly tested and investigated. In this case, people found abundant evidence that some dinosaurs had feathers where earlier reptiles didn't. So how did that happen? Someone suggested that maybe feathers had evolved from scales, being the only type of skin appendage that basal reptiles had to work with. But this wasn't something to be believed. This was a hypothesis to be tested by whatever future observations would support it if true, or disprove it if false. Then, when a better and more accurate explanation was found, that old hypothesis was discarded. If religion could correct its mistakes the way science does, there'd be no religion left. The notion that scales had become elongated and then frayed into feathery fronds was the best suggestion anyone could think of 100 years or more ago, before anyone could study genetics and embryology. They weren't suggesting that feathers evolved from true epidermal scales like lizards and snakes have on the Lepidosauur branch of the reptile family tree, but rather from dermal scutes typical of the other branch of archosaurs, being crocodilians, dinosaurs, and their descendants, birds. These scutae and reticulae on birds' legs are still commonly referred to as scales, even in the scientific literature, though we should be careful not to confuse the two. Dr. Menton, you yourself wrote an article a dozen years ago predicting what we should expect to find if evolution is true, and only if evolution is true. You asked for a trait in transition, specifically a scale feather, what you would call a skether. I'm sure you only asked for this because you thought that no matter how true you already know that evolution really is, you thought that no one would be able to show you an example of a single scale transitioning into a feather. The only evidence creation has ever asked for is whatever they think it would be possible to produce no matter what, because y'all don't even want to know what the truth is. You'd rather make believe something else. However, you asked for it, and I will deliver. The scutes on a bird's legs only look like scales, but they are actually derived from feathers. The reticulae in particular appear to be highly truncated or malformed feathers whose complete development has been stunted genetically. And it is still possible to manipulate the development of the feet in birds in embryo to produce either partial feathers or scales. Scutes. Further, these reticulae are obviously visibly similar to the button-like dermal nodules that are found in living and fossil archosaurs, including dinosaurs. And manipulating the DNA of embryonic alligators has shown that these dermal nodules can be changed into follicular spiky appendages, very similar to the early versions of feather development. Both embryological and evolutionary development as both follow the same matching pattern. Thus, experiments in evo-devo have identified a handful of scale-to-feather converter genes producing this image of the skether you predicted would only exist if evolution is true. This is exactly the evidence you asked for back in 2008. You're welcome. The science of evolution is not a credulous belief like your own dogmatic adherence to religious extremist reality denial is. I'm showing the facts that indicate. That is the definition of evidence.
In fact, if you learned in school that feathers evolved from scales, that's all thrown out now. I don't know of any evolutionists that sincerely believe that feathers come from scales. First of all, they had the wrong organ. They should have been scutes, not scales. Scutes have dermal bone structures under them like you see on alligators and bird legs and what have you. Feathers are not like scales. Scales are folds like drapery pleats. That's why the whole sheet comes off. The only reptiles that have scales are what we call squamates. That's the lizards and the snakes. Alligators and turtles, they have scutes. They're shed individually. I believe dinosaurs have scutes. Everything I've ever seen on dinosaur skin shows these button-like scutes that do not come off as an intact sheet. They come off as individual buttons.
So Menton went through the, he started out by saying that evolutionists believe that feathers evolved from frayed scales, right? Now, that's a fairly old idea. I remember it kicking around in older textbooks, but it's been replaced by a newer model, which has pointed to the fact that the actual chemistry of feathers is very different from that of scales. They're made of different kinds of keratin, and they seem to have distinct evolutionary origins. And feathers originate from within a follicle. They start out as these cylindrical structures. It therefore seems likely that the earliest feathers were probably, cylindrical, tubular structures. I'm not sure if you should call it a tube if it's got like a closed end, but whatever. They were sort of hollow rod-like structures. So that's probably your original feather. Then at some point you have barbs that grow off that, and then later on you have subdivisions of the barbs, the barbules, and there are other phases as well. Without going into all the details, that's what you would predict. The feathered non-bird dinosaurs that have been published since the mid-90s from China have that full range of diversity. The feather types that they have appear sequentially in step with the changes that we see in anatomy. So if you think of the changes, we've mentioned a few changes already to do with, tails becoming shorter and tails becoming less muscular, transition in the hind limb, changes in pelvic bone structure, changes in the shape of the coracoid, forelimbs becoming longer. Think of all those changes that happen over the course of, over the theropod family tree. The feather types that we see in these theropods change in step with those. So the most archaic of these feathery non-bird dinosaurs, like Sinosauropteryx, the first of these feathered non-bird dinosaurs to be published, that one seems to have the most primitive type of feathers. They're probably just simple, hollow filaments, maybe with some little barbs coming off them. You get to animals like Caudipteryx, you have more complex structures. You get to animals like Microraptor, which you mentioned, that has even more complex structures. You get into early birds like Archaeopteryx, the structures there are now more complex. And then again, even within birds themselves, you don't see the feathers just the same as modern birds. You see changes in the microscopic anatomy of the barbs and barbules as they are over time becoming more and more similar to those of modern birds. So in other words, you see exactly what you should if evolution is true.
You see, feathers grow out of follicles, just the way hair grows. In fact, a hair follicle and a feather follicle can look pretty similar under the microscope. All the growth appears at the bottom, down here, called the growth collar. The cells divide. The yellow is a tube coming down from the surface of the skin, basically a tube of epidermis. And what looks like a kind of a really thick, complicated hair, shown in green here, comes sliding out of this tube to the surface. Now, at first, the hair is formed inside of a shell. We call it a pin feather. This is a cute picture. It's a white cockatoo. It's only 6 weeks of age. And look at its feathers. They look like a bunch of little white pointed structures. These are called pin feathers, and they can be kind of sharp on a bird. You put your finger on the end, they come to a pretty sharp point. The feather develops inside of that shell. And when the shell breaks off, the feather unfolds, and it's arranged like a cylinder inside. A good friend here at the museum, Tim Lovett, did an animation for me that'll help us see how feathers grow. From where we see the brown, this is where the shell has broken off, and these are the barbs of the feather that make up the feather vein. And the feather will grow out of that. You're supposed to be able to get a movie out of that. I don't know why not. There it goes. So the barbs are helically wrapped, and when the shell breaks off, they unwrap and swing out. And that produces the feather vein. Now, we're not showing a lot of the detail. Each of those little lines of barbs have little tiny barbs called barbules. Well, there's a lot of different kinds of feathers that birds are able to produce. The big ones that are in the tail are called remiges, like one. The flight feathers are on the wings, and always they're attached to the bones themselves, not to skin. They're attached to bone. At the end of the flight feather, there's a ligament that goes right into the bone with no intervening muscle. And in the case of birds, the primaries are on the bones of the hand. The secondaries are on the bones of the ulna. The radius is the bone on top here. One of my favorite feathers is the one that's listed as 4 there. It's shown way too big. It's out of scale. It should be so tiny you can't even see it compared to the other feathers. It's called a phyloplume. If you've ever plucked a chicken, and I'm finding there are fewer and fewer people who have, but I remember my mother used to pluck chickens to cook them. And when she got all the feathers off, there were like little tiny hairs left. You could actually see these hairs if you look carefully. She held the bird over the gas stove to burn these off. And once you had those off, the bird was ready to be cooked. Those little tiny hairs don't grow up to be big feathers or anything. They stay tiny, and they're called phyloplumes, and they are believed to be sensory structures. They are very tiny. They're embedded among the bigger feathers, and when the feathers are moved, as you know, the feathers have muscles, the bird has to get some information of what position is this feather in versus that one, because in flight that all has to be adjusted. That information is presumably being picked up by these little tiny phyloplumes picking up the signal, sending it to the brain. Bird then can adjust its feathers in flight. Feather number 6 down there is a down feather. You've all seen those. They're particularly good for warmth, whether you're trying to brood eggs or have a sleeping bag. And this is the way a down feather looks in a scanning electron microscope. What it is a feather shaft with a bunch of barbs, but the barbs don't have any little barbs called barbules. They're just separate. So it traps a lot of air. In fact, you know what? It looks like Charlie Brown's Christmas tree. Have you noticed that a little bit? Here's the basic anatomy of what we call a pennaceous feather. These are the most complicated ones. You have the shaft, or rachis. It's in position 1 there. And then for each of these shafts, you would have 2 veins, one on each side. So you see the 2 veins listed. And then each of these veins, for an average size feather, would have about 400 barbs coming out of it. Those are the things you saw unfolding out of the follicle. And the barbs protrude from the shaft, and from each barb, there are little barbs called barbules. This is getting ridiculous. And in the next picture over here, you see a barb here, and it has barbules. The brown barbules are what we call anterior barbules. The yellow ones, it's just a color we've put in to keep them separate, are called posterior barbules. And the anterior barbules have little hooks. And so each anterior barbule has about 20 hooks. Well, do the math on this and figure out how many hooklets there would be in a swan. The number is outrageous. All of this hooks together, we used to think it was like Velcro. You know, you just have a bunch of hooks here and some loops here, and you just sort of moosh the 2 together and hope a bunch of the hooks grab the loops. It turns out the feather is not like Velcro. The feather is like a zipper. And when that bird runs its beak with its lubricant out the feather, starting from the base of the feather, all these little hooks zip up like a zipper. Every hook zips. You don't skip anything like you do in Velcro.
So then what about the feather types that dinosaurs had or had that modern birds don't have? I mean, like Psittacosaurus or Triceratops. Can you explain that for the audience?
Yeah, well, that's a can of worms right there, because that is an area that's currently under really active investigation and debate within, those paleontologists specifically interested in it. It's one of those things where we're working on it and there isn't agreement at the moment. So yeah, really interestingly, fiber-like filaments that probably have the same developmental and genetic origin as modern feathers are not just present in theropod dinosaurs. So first of all, in theropods, we've just been talking about maniraptorans and related theropods. They're in those guys. They're also in ostrich dinosaurs. They're also in tyrannosaurs. At least some tyrannosaurs have these filamentous feathers. But then you've just mentioned dinosaurs that come from a totally separate branch of the dinosaur family tree, part of this group called the Ornithischians. Some of those have filaments. So Psittacosaurus, which is an early member of the Ceratopsian group that includes Triceratops and so on, that has about 100 of them on the tail. There's a small Chinese dinosaur called Tianulong, which has them. There's another one from Russia called Kulindrodromius that has them as well. So are those filaments of the same genetic and evolutionary origin as the filaments of theropods? Then there's also pterosaurs, which aren't even dinosaurs. Pterosaurs have filaments as well. So does this mean that filaments, which may be evolutionarily homologous, have the same developmental and evolutionary origin as feathers, does this mean that those structures actually evolved right at the start of the group that includes pterosaurs and dinosaurs? If you did a straw poll among paleontologists interested in this particular area at the moment, you'd probably find, I'd say at a guess, you'd find about 70 to 80% saying yes, that probably is the case, that filamentous primitive feathers probably did originate in the common ancestor of pterosaurs and dinosaurs. But you'd have another group who would say, no, we think they've evolved sort of 2 or 3 times separately. And at the moment, the evidence isn't there to sway it either way. A few big studies have been done where people have, mapped the distribution of these structures onto family trees, and they make a few assumptions that might be questionable. But what we really need is a Triassic archosaur that's ancestral to both pterosaurs and dinosaurs and preserves integument, preserves the skin and stuff on the outside of the skin. Only then will we be more confident in this argument. I mean, my gut feeling is that the filaments probably are primitive for the pterosaur plus dinosaur group, but I won't be offended if it turns out they have evolved 2 or 3 separate times, because we see that kind of thing all over the tree of life as well.
Well, I mean, dolphins are mammals, but they don't have a whole lot of noticeable fur. So, dinosaurs probably had a very similar condition, as did pterosaurs. So the pterosaurs had something, again, for the audience, not yourself. Pterosaurs are known to have had what they call pycnofibers, which is something not even downy. Like Sinosauropteryx had something like downy feathers, like a baby bird would have. But these earlier forms, it's almost fur-like, virtually indistinguishable from fur, because hair follicles are a very simple structure. But with Triceratops, what makes that interesting is that the fiber is there's large circular spots on Triceratops skin that look like the base plates, the bases for feathers. But if it's on a Triceratops and there's only like one every few inches or so, and they're this big around, well, then that would imply that these are more the spike. I forget what the name of the undeveloped feather is when the feather begins in its form. It's like it comes to a spike. And what was that? It's called pin feathers.
Yeah.
Yeah. But there's just some animals that got the pin feather as a scoot, and then it never changed from that. So but it was made of a different material than scoots are, so it didn't fossilize. It or wouldn't have except under pristine conditions. So Triceratops likely had, and we can't prove this, covered in spikes made of pin feathers, as if it wasn't already spiky enough. But that wouldn't wouldn't that mean that Triceratops and Psittacosaurus would have to be classified as birds?
Pin feathers is specifically where you've got the early feather emerging out of the follicle, and there's a semi-translucent sheath that covers it, which is called the pin. So Menton was a bit misleading in his video. He didn't say that. Yeah, you actually describe growing feathers as in pin when they've still got that sheath on the top of them. The structures in, sorry, going back a little bit, the structures in pterosaurs, very interestingly, there was a paper published again on one of these Chinese fossils, a new kind of Jurassic pterosaur that has, again, like 5 or 6 different kinds of pycnofibers on it, which include long filaments that are different from our hair, and also more complex multi-branch structures which are like long filaments but with a starburst-like pattern at the tip. So yeah, pterosaurs seem to have a bunch of different kinds of these pycnofibers, some of which are essentially indistinguishable from the simpler structures of non-bird theropods. So some experts think that that's good support for the idea that the pycnofibers of pterosaurs are evolutionarily homologous with the fibers of theropods, and therefore also with the filaments of ornithischians like Calindrodromeus and Psittacosaurus. So the Triceratops structures you're talking about now, they're known from this specimen called Lane, who's in Houston. So I don't know if you've been to see it. I would love to, but yeah,
gave me a private tour.
Wow, very lucky. Yeah, it's odd, isn't it? They look like these spines, kind of pointed nipple-like structures. Now it's really tempting to think that, again, are these homologous to the quills of Psittacosaurus? If we know other members of the horned dinosaur group, the Ceratopsian group, if we know that other members of the group have filaments, is this some kind of indication that Triceratops and maybe other ceratopsians as well have filaments too? I would say at the moment we just can't say until we get a better fossil. I would love it if it's true, but I also think there's the possibility, if you look at the range of variation that you see in the skin of certain lizards today, within a family of lizards, you can have species that have got completely flat scales, others that have got kind of spike-like structures emerging backwards from the scales or in the middle of the scales. It wouldn't surprise me if we find out there's that kind of variation in some of these other dinosaur groups. It might not be anything to do with the feather story. It might be, but as always, we're always looking for better fossils.
Well, let's just look at a series of pictures in the electron microscope now of feathers. This is a low power view. You see the shaft in the middle, a vein in each side. We see lots of barbs, and in between are the barbules. Here's a higher power view. You can begin to see the individual cells as little bumps in there. And then a higher power view, the posterior barbels are on the top here, the anterior underneath, they're crisscrossing one another. Higher power view, posterior barbels on the top, anterior underneath, they have the hooks, but you can't see the hooks, they're covered by the posterior barbels. So let's remove the posterior barbels, and there are the little hooklets that hook this all together. Well, let's put the whole feather back together now. You can see anterior barbels run in this direction, posterior run in this direction. The hook is not engaged. It'll grab a little groove in the posterior barbel like this. It's like a bracket. So you need a hinge that will allow that hook to swing over and hook onto the bracket. Can you imagine this all being dumb luck coming from a frayed scale? I mean, what a relief. Isn't it great to be Christians? We not only have heaven waiting for us, but while we're here on earth, we can be rational. This is not dumb luck we're talking about here. And it certainly isn't a dinosaur.
It certainly is a dinosaur, as I've already demonstrated all through every episode of the series so far, while you have deliberately misrepresented everything relevant to that relationship, and your education gives you no excuse for such obvious ignorance. If something is complex, it's not dumb luck, but more likely that it took millions of years to develop via deterministic processes, which will eventually produce a high degree of precision, especially when acting on molecular structures, which are always inevitably intricate anyway. Yet you pretend that all these things were conjured, spoken out of nothing, by the incantation spell of a magic invisible genie, and you call that being rational? The word rational is commonly defined as having sound reason, which I don't think that you do, of being reasonable, able to reason, and amenable to be reasoned with. But that doesn't apply to you, because you signed an oath when you were hired by Answers in Genesis, wherein you swore to reject any and all evidence of every kind from any source if it contradicts a wholly unreasonable interpretation of your sacred fables. You make believe impossible nonsense for no good reason, having neither evidence nor logic to support any of your erroneous and ridiculous assumptions, which you defend against all reason and despite overwhelming evidence against every part of your obstinate stoicism. Yet you are forbidden to ever admit when you're wrong, even though being wrong is your job description. You are a professional propagandist and an irrational liar, Dr. Menton.
Let's turn the feather over. Now the hooks will be facing down, go up to higher power, there's the hooks. And now we'll hook everything up for you. Each hook has grabbed a groove on the posterior barbel. There's a little guide probe that guides the hook in, and each hooklet has a little thin area that's like a strap hinge that allows it to move. It's no wonder when Charles Darwin was once asked about the peacock's tail, whether his evolutionary idea could explain that, Darwin said that the sight of a peacock's tail made him sick when he looked at it.
Natural selection was only the first of several evolutionary mechanisms to be identified thus far. Darwin realized that natural selection could not explain the peacock's tail, and this prompted him to work out a second evolutionary mechanism, sexual selection, which does account for the peacock's tail, as well as a wealth of similar examples of healthy gender expression in many other animals. So you're making fun of Darwin for being presented with a problem without mentioning that he also solved it. You know he did. But you don't want your audience to know that, because your job is to spread misinformation, to conceal, confuse, and distort the truth behind your smoke and mirrors, to make believe things that you already know are not really true.